And the rest of you guys have it. All right, so normal running of RIP over here. Network 10.0.0.0 for RIP. On the router, on the ASA side, basically the same way. That's on the ASA side. Let's do the router first, and then we can check the route on the ASA. Router 3 over here. So that enables it on router 3, and now on the ASA. Let's check. Show route. Give it some time, it's RIP. So it does take a bit for it to propagate. Up to 30 seconds, there you go, 10.330 is over there. Any questions about that? Give me the go ahead and we'll get started with the sorry about that. So I've created it. Now I need to apply it. How do I apply it on the router? Just like I did for EIGRP. So I would say interface F0/0. The command is slightly different because it's RIP. I say RIP, IP RIP authentication. Mode MD5. You can also do text, by the way, on RIP, whereas EIGRP is only MD5. Keychain is ABC. I just call it the same. So I'll copy this. And I shall paste it over here onto router 3. And the same thing, same concept over here is going to be done under the interface for RIP. So I'll go and do it in Notepad and then paste it. ASA1, interface gig 0/2, because that's the interface towards router 3, the RIP router. RIP authentication. Mode is MD5. RIP authentication. Key is Cisco 123, because that's what I called it on the other side. Key underscore ID. In EIGRP is key dash ID. Over here, key underscore ID. One subtle difference is not that big of a deal because you can pull the question mark and it'll tell you that. Let me just show you. I won't type it. I'll just do it over there. But I want you guys to see it's going to be key underscore ID over there. So you guys can see even if you don't remember, it's not that big of a deal. So RIP authentication, mode MD5. RIP authentication, key was Cisco 123. And then if you don't remember it, just do a question mark. It'll show you that there's only key one option, that's key underscore ID 1. Show route. It's still there, so my authentication is working properly. Good stuff. You guys are okay with this? You understand that? Any questions about this? Yes, no, good. All right, so RIP is done. Let's do OSPF now. I'll just copy this part and I'll modify it for OSPF. OSPF I'm running on the outside, router 2. Router OSPF 1. Let's give it a router ID. We'll say 2.2.2.2. Network, I'll say 192.1.20.0. This is on the router, so inverse mask, area 0. Network, let's say 199.110. Area 0. Network 200.110. Area 0. On the ASA, almost the same. Network is 20.0. The only difference is the mask is normal, and I'll probably put the router ID command over here. So let's just do the ASA first. Running OSPF, running on the 20 network in area 0, and then I'll do it on the router itself. Copy. Now you need to be patient with OSPF because it takes about 40 seconds for it to establish the neighbor relationship. It would have seen it, but it goes into a waiting state for 40 seconds before it establishes a neighbor relationship. So we'll wait for that. It will come up on the screen and display that it has established a neighbor relationship once it's done. There you go. So your neighbor relationship with what? With the firewall, between the firewall and the ASA at this point is complete. And you should be able to see the routes over here. Show IP, no, not over here because I'm not advertising anything on the ASA, but on the ASA, I should be able to see the routes. The 199 and the 200 route as OSPF routes. Take a look. Good so far, guys? Everybody fine with this? The other thing that I would also do on the ASA is probably a route outside 00, pointed to R2, just for a default gateway point. Once this part is done, I can now move on to the authentication part of it on OSPF. OSPF, even on the router side, it does not support the keychain concept, just like on the firewall. What is the significance of neighbor command in OSPF on ASA? The neighbor command is run on a special network called the non-broadcast multi-access network. Non-broadcast multi-access network is a network where you cannot do neighbor discovery through multicasting. So you need to do it based on unicast. So if you change your network type under the interface to non-broadcast multi-access, you can use the neighbor command. You can also do it on the router, same concept. If you want to do unicasting in OSPF, like unicast neighbors in OSPF, you need to do it based on neighbor command. But before you can do that, the actual interface needs to be using the OSPF network type called non-broadcast multi-access. Got it? All right, good. So on the router, if I want to do authentication based on MD5, IP OSPF authentication message dash digest IP OSPF authentication. No, sorry, IP OSPF message dash digest dash key, TID, key one, MD5 like a keyword, and the password, the key itself. So both the TID and the key string are right there. TID is 1, key string is Cisco 123. I'm just keeping it consistent with RIP and EIGRP, although it could be different for different interfaces. And the same thing applies on the ASA. Just take the IP out, and the rest is the same. So the authentication for router or the firewall for OSPF is almost identical. The difference being what? Did I copy the router portion? So I'll go to router 2. Now my neighbor relationship should come down in 40 seconds over here. Why? It takes about 40 seconds for it to realize, hey, that's the wrong password. And if you do a debug, you can actually see it. The other one came down, the neighbor relationship came down. Over here, I'll keep on telling you, hey, invalid authentication, so I'm ignoring the hello packet, which is sent every 10 seconds. Did I? Okay, I haven't pasted it yet, right? So I need to paste it anyways, gig 00. Over here, now I can go to the ASA. This copies it automatically. It had gone down on R2. Now it's coming back up. So it's using key ID of 1. The authentication's up. I'll undebug it. You can also see if it's doing authentication or not by using this command, show IP OSPF interface F0 or F0/0. It should tell you that you have MD5 enabled, just to see if it's doing it or not. So that's the authentication part for OSPF as well. So I've shown you how to do on the routing as well as how to do authentication with the routing. The last thing that you need to do over here is redistribution. You have OSPF running on the outside, EIGRP on the inside, and you're running RIP on the DMZ. So you need to be able to redistribute between the different routers. Nothing major, nothing tricky, just basic redistribution. So I'll put that also over here. That's the purpose that's the reason I do the 3 different protocols, so I can also show you that. So on the ASA, because it's running all 3 protocols, I want to do redistribution into, let's say, RIP. I'll say redistribute, sorry, router RIP, redistribute OSPF 1 with a metric of 1 hop count. You need to put the metric of the destination routing protocol. In this case, I want to send OSPF and EIGRP 100 into RIP with a hop count of 1. All right, that's into RIP. Right now, if I go before and after, on router 3, which is running RIP, I will not see any routes because I'm just directly connected to the ASA and he does not have any routes. But as soon as I do my redistribution over here into RIP from OSPF and EIGRP, those routes that I learned from OSPF and EIGRP, I'm sending them into RIP. So now R3 should get the outside routes, which are OSPF routes, and the inside routes, which are EIGRP routes. See, a whole bunch of RIP routes came in. So 10.1, 10.11 from the inside, the 199, the 200 from the outside. In the route switch exam or route switch class, I go into much more detail about the RIP and about redistribution of the routing protocols. Here, it's pretty basic, nothing major. Just put the metric in and I'll start redistributing. Now, the next one that I want to do over here is into Let's do EIGRP now. Router EIGRP 100, redistribute. In here, I'm going to be redistributing RIP. EIGRP uses a metric of bandwidth, delay, reliability, load, and MTUs. 2, 10, 10, 1, 1, 1, or even 5 ones. You need to have all 5. That's bandwidth, delay, reliability, load, and MTU. The number doesn't matter. OSPF 1, metric 11111. It requires the metric. As you're going from RIP, which uses a hop count as a metric, or OSPF, which uses a cost as a metric, into EIGRP, which the metric is different. So you need to do that seed metric, the initial metric that you're going to be sending it. So I'll copy this and post it again to router, ASA. So once I paste it over here, it's going to be doing the redistribution into EIGRP, and you'll see these routes in EIGRP as external routes. And 3 and 190 to 168.1 from the DMZ, 20, 199, and 200 from the outside. And the last redistribution that I want to do over here is into OSPF. It has its own small little quirks. Router OSPF 1, redistribute RIP. It does have a metric by default. Metric is 20. If you want to change it, you can set up the metric like 20 or 30 or whatever number you want to use. That's a cost. But you need to use the keyword subnets. Otherwise, it just redistributes major networks. So if you want subnets to go across like 10.1 or 10.3, which are subnets, you need to put the keyword subnets over there. So redistribute EIGRP 100, metric, let's say 30, and subnets. Copy it. I'll go down over here onto ASA1 again. Oops, redistribute. Now on R2, you should see all the internal routes, which you might not want to do, but I just want you guys to see that it is possible to do that. Any questions, guys? You guys understand the routing bit over here? And these are the things that you need to be aware of in terms of routing on your CCI security exam. Questions, guys? Easy peasy, yep, but it's there, it's important. Just want to make sure that everybody is on the same page regarding this. This is something that is tested on the exam. Yes. And if you haven't done this before, it's a critical step because you need to get the routes across. That is assumed. Good. Now let's do the security stuff. That is the NAT. There's no key lifetime and all that type of stuff now. That's what you're talking about, right? Send and accept lifetimes. Yeah, you don't worry about that. I would have explained it in detail if it was there. But this stuff that I've done is done. It's done for a reason. It is important from the exam perspective. So make sure you are completely aware of the things that we just discussed over here. All right, so with that in mind, let's go get started with the next topic, which is natting, which is to me the main topic for today. This is an important topic because this is something that is done generally on the firewalls on a regular basis. And this is something that you can expect to have on the exam. All right? Any CCI exam that you take for security will have natting in there. So be careful, be aware of it. I want to do a change over here because I saw something that was not right. So what I'll do I'll bring my outline up. So this part we had done the last time around. We're doing this over here. Dynamic NAT and static NAT. Dynamic PAT and static PAT. Destination NAT, manual NAT. So I had not put the word NAT at the end. So what I want to take a look at is NAT. What does NAT do for you? If you take a look at your diagram over here, I have my inside networks. I'll explain. The normal NAT that you do is source NAT, and you'll understand that in detail. Now, if you take a look at this address over here, 10.11.11.0, or for that matter, 192.168.1.0, these are private addresses. Everybody aware of the RFC 1918 addresses, right? The 10.00/8, the 172.16.00/16 through 172.31.00/16, or the 192.168 range. These are all private addresses. You guys agree? They cannot be used on the internet. Okay? Now, if these are my internal addresses and I want to go out to the internet using these addresses, I can go out, but I will not get a response back because the internet routers, as a policy, will not route to these RFC 1918 addresses. So I need to change this address. Now, whenever you do natting, you need to understand you will always do natting in two directions. From one to, you'll translate from the original to the translated address. One way. On the return packet, it'll translate from the translated address back to the original address, the real address. All right. For example, if I set up a NAT pool over here, that will translate my inside people going out to the internet. So I buy a pool of addresses from the internet. Let's say from my ISP, I have bought for my company this Class C address. Okay. Now I have a full range of 254 addresses available to me. Let's say at any given 100 hosts going out from the inside simultaneously. Okay, 10.11.11.0 from that network, 100 hosts go out at the same time. So what I can do is I can create a pool of 100 addresses from here. So for example, I'll pick 192.1.20.101 through 192.1.20.200 as my pool of addresses. Basically, what I'll say is anything that comes in from the inside network going towards the outside, I want them to use this pool of addresses. Everybody okay with that? So once I configure that, I'll show you the configuration part of it. But before we get into the configuration part of it, I want you guys to understand something. In this type of setup, when the packet leaves your router or your device, let's say this is your internal device, let's say a PC over here. Somebody's sorry, guys. So this is a PC over here that's trying to go out from the inside to the outside. His address, let's say, is .5. So when he leaves, the packet looks like this: 10.11.11.5 going towards, let's say he's going to the internet. 2.2.2.2, somebody on the internet, somewhere around over here. All right, it hits the firewall. What does the firewall do? It will take this packet, it is going to create a translation table and pick the IP address from that pool of public addresses that I had assigned. All right, so once it picks the IP address, it will create a pool. In that pool, it'll say, I have taken address 192.1.20, let's say 125, for example, and I have given it to 10.11.11.5 going out. So what it does is in the packet, the same packet that came in as 10.11.11.5 going to 10.2.2.2, it will change that over here to 192.1.20.125. The destination address will be unchanged. All right, hits the internet. Good. This guy gets it. He wants to respond back. Who wants to respond back? The 2.2.2 address wants to respond back. He sends a packet out. I'll put that in blue. When he creates the packet, the return packet, source and destinations are flipped. Now the packet looks like this. This is the return packet coming in. Ccie Sec gets it. It checks its translation table. It sees that 192.1.20.125 was translated originally to 10.11.11.5. So what he does is he translates the packet back into what? The original address. What was the original address that actually left the PC? And that IP address would have been kept inside your translation table. Now, what happened over here? I want you guys to realize that two types of translations happen. It translated from where to where? It translated from the inside to outside, and it translated from outside to inside. Does that make sense, guys? Everybody okay with this? So it's a two-way translation. You cannot do a one-way translation, because if you translate one way, the return packet does not get translated. If I did not do the return translation over here, and I let the packet come in, this blue packet, it's going to come into 192.1.20.25. There is no actual address that's 20.25. I need to translate it back to the original so that it gets sent to the appropriate device. You guys understand that? What I'm basically trying to tell you guys is the translation needs to be done in both directions. If you do it one way, it's not going to work. All right. Now, my question to you guys, and I want you guys to pay attention over here. This is where a lot of confusion comes in, especially with the terminology. In this type of setup, is it called source NAT, or is it called destination NAT, or is it both? From inside to outside, I changed from 10.11.11.5 going to 2.2.2.2. I changed it to, I changed the source, right? I changed this address to, I didn't change my destination, it remained. And on the return packet, when the packet was coming back in, it was coming in like 2.2.2.2 as a source to this guy. And I changed that packet to the original IP. Right? So this is my source, this is my destination, this is my source, this is my destination, source, and destination. So what is this NAT called? Is it source NAT or is it destination NAT? Now, this is where I want you guys to pay attention and remember this. The word source or the word destination NAT is very, very confusing. It has nothing to do with the source IP or the destination IP in the packet. The word source, and this is something that you need to remember. The word source basically represents your internal address. Is your internal address getting translated or not? So when I talk about source NAT, I am going to be doing source NAT when I change my address. My address changes. Do you guys understand that? If my address changes, whether it's in the source part of the packet or the destination part of the packet, it is called source NAT. So what I accomplished over here, the entire thing is source NAT. I did not do destination NAT over here. So I want you guys to understand, destination NAT does not mean changing the destination IP address in the packet. Or the source NAT does not mean changing the source address in the packet, because if you look at it, the return packet, what am I changing? Am I changing the source or the destination? Everybody locked in, guys. This is important. Is changing the destination, but it's still called source NAT. Nope, not again, Emma. Source NAT is when my address changes. Now, let me give you another example of that, where I'll show you that even though the packet is from the outside to inside, it's still called source NAT. Correct. Inside NAT, outside NAT. Outside NAT is your destination NAT. Inside NAT is source NAT. Okay. Now, let's take another example over here. Let's say this is my firewall. This is my DMZ. DMZ is where I have my public-facing servers. This is my web server. This network over here is 192.168.1.0. And this web server is .11. This is my internet. Can this address be accessible from the internet? You guys, I want yeses for this particular part because this is very important. It can be, right? Interaction from you guys, please. So it cannot be accessed. I need to translate it. So you need to statically translate it, because I cannot tell my users, hey, I don't know what the address is. It might change tomorrow. So I translate it to a static address. So I'll change it. Let's say I translate on my firewall. I set up a static translation, which is done for your public servers. I'll say 192.168.1.11 is always going to be 192.1.20.5 on the outside, let's say. Remember, 20 was my range of public addresses. Good. So I'm changing my address from 1.11 to what? 20.5. This is a static translation because I'm statically translating this address to that address. Now, I want people from the internet be able to access my web server. So far, so good. The whole purpose of this web server on the DMZ is so that people from the internet can access it. So I'll open up an ACL entry to allow access. To web server. Somebody on the internet accesses this web server. When he accesses it, what does the packet look like? What does the person on the internet type in? Source address, I don't care about it. Destination address is going to be what? For that person coming from the outside, trying to reach your web server, what is he going to type in? 192.1.20.5. Agreed? The firewall intercepts that request, says, oh, 192.1.20.5 is really what? This guy. And translates that packet to what? XXXX, which is the address of the client, doesn't change, but this guy would change to what? Right? And on the return, when the packet goes back, This packet will leave my web server as this. But again, the firewall will do what? As I said, translation is always in two directions. He's going to translate 192.168 back to what? 20.5 XXXX. So now, who initiated that connection, guys? From the outside. Towards what? This address. Agreed? Yes? Is this source NAT or is it destination NAT? It's still source NAT. What is the definition of source NAT? If my internal address is getting translated regardless of the direction of the access, it is called source NAT. The word source is you or mine address. You understand that? Ahmed, you have the issue with that? You understand that? I will show you a destination NAT as well. But this is source NAT. Everybody okay with that? So when you go on the internet and your address is changing regardless of the direction of the access, whether it's from in to out or out to in, because your address is changing, it's called source NAT. So normally, 99% of the time, you're going to be doing source NAT. Think about it. Do you change the address of somebody accessed on the internet? Do you change Google's address internally? You don't. If you did, that would be called destination NAT. If you change their address, their means what? The foreign address or the remote address. If you change the remote address to appear as a local address, that would be called destination NAT. Destination, why? The word destination is representing the remote device. Destination NAT. If the external address / remote address / foreign address, whatever you want to call it, changes, it is called destination NAT. The word destination is them. Them means what? Remote. Got it? 99% of the time, you are doing what type of NAT? Source NAT. And we don't even call it source NAT, we just call it NAT. So when we talk about NAT, NAT is source NAT. I'll show you that as well. You guys understand this for right now. So 99% of the time when you talk about NAT, it is source NAT. That's why people don't call it source NAT, because they just call it NAT. And that's the only thing that they know about is NAT. Now, why would you want to do destination NAT? Why would you want to translate them, the remote devices? I'll give you an example of where I had to use it in my own experience. I used it a couple of times. Generally not done. As I said, it's 99% of the time you're not going to do it. Let's say I had a device. Let's say, no, not for redirection. Let's say I had a device. Redirection you can also do with PAT, for instance. So let's say I had a device over here, not a PC. Let's say a IP camera, maybe a mainframe, something like that. Without a default, it does not have routing capabilities. No routing capabilities means what? It doesn't, I don't mean it's not running a routing protocol. I mean, it doesn't even have the ability to put a default gateway. Can only communicate on the local segment. Nowadays, very rare to get, but in the initial phases of IP, this is something that used to happen where the devices would keep the operating system light when memory was very expensive and not as much to go around with. So in those cases, you would not put the default gateway over there. So now he would not be able to communicate to anybody other than devices locally. Let's say this was an old mainframe. All right, this is the 192.168.1.0 network. It's an old mainframe device that does not have full routing capabilities, and it needs to communicate to some other mainframe somewhere else. And this mainframe over here is, let's say, 150.1.1.1. He's coming in and he wants to reach this guy, this internal mainframe. The first thing that I need to do with this mainframe is translate him so he can be seen on the outside. So what do I need to do over here? First thing, normal stuff. I want this mainframe to be available on the internet. So I do source NAT. How do I do source NAT? 192.168. Let's say this device over here is 51. 51 is seen on the outside as, let's say, 192.1.20. Let's say 25. So far, so good. You guys understand what I did over here, what I did in the previous example. Don't worry about the syntax. I'll show you that. So now this mainframe, when he wants to communicate to my mainframe, he's going to send the packet out. He's going to have a source of 150.1.1.1, destination of what? You guys agree? Good. If I let that packet come in, hit my firewall, and the firewall just translates, does normal source NAT. Source NAT is change my address, which is 20.25. A packet coming into my device over here, my mainframe, would look like this. 150.1.1.1 coming into 192.168.1.51. Agreed? Hits the device changes the source destination. Now the source is 1.51, destination is 150.1.1.1. He does not have a default gateway. If he does not have a default gateway, he can only communicate to whom? He can only communicate to devices on my local segment. You guys agree? Because he does not have a default gateway, he can only communicate to the local segment. Understood? So it would not be able to communicate back to this mainframe. Why? No routing capabilities. So what do? In this case, what I'm going to do is when the packet comes in from 150.1, this is the destination NAT part of it, where I translate that address. Which part? This part? The whole thing from where? All right, I'll do it real quick. I cannot do the whole 15-minute lecture, My device does not have routing capabilities. You understand that part? That is 15 minutes. So do you understand this device does not have routing capabilities, does not have a default gateway capability? Understand that? Okay. What device can it communicate to? Local segment only? Okay, done. Now this device has an IP address of 192.168.1.51 on this private address. I want this address to be available on the internet, so this mainframe over here can access it. Understood that? I translate it. I translate my address to 20.25. Understand that part? Because I'm changing my address. It is called source NAT. Understood that part? Okay. Now, this mainframe on the internet wants to access my mainframe. He's going to create a packet as 150.1.1.1 towards 192.1.20.25. Any problems with that? Okay. Hits the firewall. The firewall translates 192.20.25 to what? 192.168.1.51 based on this translation. Good? Now it's translated to 192.168.1.51, which is this device. The firewall will send it over here. Now, when he gets a request, he will flip the source and destination. Now the destination becomes the source becomes the destination. Agreed? Okay. Can he send the packet back 150.1.1.1? He does not have a default gateway, so keep that in mind. No routing capabilities, can only communicate on the local segment. Remember that? Ahmed, you're there. Do you understand that? So to counter that, so to fix that, I'm going to translate the remote address, this address, as if it's a local address. So I'm going to do a destination NAT over here, specify that I want 150 on the outside, a packet coming from the outside with the source address of 150. When it comes in, I want to change that source address to 192.168.1.x, some address that is not being used on this local segment. So I'm treating the remote address as if he's a local address. So this packet, when it comes in, the source address over here is going to change to what? From 150.1.1.1 to 192.168.1. Let's say I put it as 79, just any unused address. I'll do the translation over here. Now I'm changing the source. How do I call it destination NAT? Do you remember the definition of destination NAT? What was the definition of destination NAT? Changing of the remote address. Is 150 a local address or a remote address? It's a remote address. If I'm changing the remote address to a local address, it's called destination NAT. I'm actually changing the source of this packet coming from out to in. I changed it to 1.79. So when I receive it over here, I'll flip the source and destination. Who am I communicating to now? From 192.168.1.51 to 192.168.1.79. You can change it to the source of the inside interface of the firewall or any address on that particular network. Any unused address on that network account. So now when I get this packet, says, oh, it's on my local network. I don't need a default gateway for that. I'll send an ARP because it's on the local segment. I'll have the MAC address already because of the packet being sent from the firewall, the MAC address of the firewall. So I'm going to communicate to the firewall. He gets it. He's going to translate that packet back to what? The original form. So the public form. So the packet leaving over here will be from 192.1.20.25 going back to 150.1.1.1. So that's where you use destination NAT. Very, very rare, but that's where you use it. Understand it? So that's, a lot of people confuse this because they don't use it as often. And because they don't use it as often, normal NAT is treated as destination NAT, which is wrong. So here, both source and destination translation are happening. Absolutely correct. Good. You can do it as twice NAT. Different vendors do it differently, but general terms for source NAT is source is you. Your translation. If your address is getting translated, it is called source NAT. If the remote address is getting translated, it's called the destination NAT. I know different vendors call it differently, but in Cisco, this is destination NAT. Coming back to your question, Ibrahim, is it twice NAT? Twice NAT and I'll explain that to you guys. On the ASA firewall is a mechanism. Double dating. I was like, man, I'm not into that business. Double NAT is this NAT. I was like, man. This is twice NAT. But again, twice NAT, the way it's done, I'll explain that. Oh yeah, I guess so. Twice NAT, I'll explain it to you guys what it is, but this is an example of twice NAT or double NAT. Good so far, you guys understand that. So this is the concept of NAT that I wanted you guys to have. The actual implementation of it is pretty basic. What we'll do is we'll take a short break, 15 minutes. When we come back, I'll show you the implementation. At that point, now that we've discussed it, these NATs don't take that long. So when we come back, our objective, where was that? This guy over here. Our objective is to take a look at all these different NATs. Is there a way to check the destination address to perform destination NAT? It's something that you need to communicate to them and ask them, what is the address that you're going to be coming in as, so I can translate you guys to an internal address. It's between you and somebody else. It's not something that you do on the fly. So you need to communicate to the other guy on the other side that you're doing it with. All right, so it is 7:21 right now. Let's take a 15-minute break. When we come back, our objective is to knock out the actual implementation of these. I'll show you how it's done. Understand this portion well, because when we do FTD, this concept doesn't change. The ASA or FTD, in terms of the actual working of NAT, is the same. It's just the configuration part will be different. So let's take it from 7:21 based on this reference clock to 7:36, 15 minutes. We'll come back and do the implementation after that. Break time. Hey guys, everybody back? Yes, yes, please. More than 4 people, come on. There's about 26 people logged in. All right. So let's go get started with these different type of NATs. We'll start with dynamic NAT, then we'll take a look at static NAT, dynamic PAT and static PAT. Then we'll take a look at destination NAT, manual NAT. Another word for this is twice NAT. All right. So we'll take a look at all these. So with this in mind, let's get started with dynamic NAT first. Taking a look at our example over here, our network over here, we have the ASA inside, which is 10.11.11.0. That's where my internal users are at. I want my 10.11.11.0 and the 10.1.1.0 networks. Or let's start with 10.11 as an example. Going out to the internet, they need to be translated to a pool of addresses. I want to dedicate a pool of addresses of 192.1.20.101 through 200 to be set aside. So let me put that scenario to you guys over here, and then we'll start configuring it. We'll take a look at source. And again, everything is going to be source until I specify destination, but I'll write it anyways. Source dynamic NAT allows internal users to go out using a public address from a pool defined on the firewall. All right, syntax. Number one, define the pool. Command is object network and give it a name, whatever you want to call it. Let's say pool one. Range 192.1.20.101 to let's say 192.1.20.200. So that's my pool of public addresses. That's how you define a pool. Number two, specify the address that can use the pool. And that's done again by using an object network. Let's call it inside net. Subnet is the keyword, 10.11.11.0. Anybody on the 10.11.11 network should be able to use that pool to go out. And that's basically it. Another word for this, another two words that you can call this. This is also referred to as object NAT or auto NAT. This way of doing translation where you create a pool and specify who can use a pool based on the object network command. All right. So what are the other two terms used for this? Either object NAT or auto NAT. Good so far? That's a generic term for it. So let's go ahead and do it. I'll go to my firewall again, which is, if you look at your diagram over here, ASA1, I want my 10.11.11 network to be translated as 20 dot something on the outside. So create the pool, object network, give it a name, pool one. Actually, I made a mistake. It is case sensitive, so pool with an L capital. Range 20.101 to 20.200. That's my range. And then object network, inside net, just a name again, subnet, 10.11.11.0, 255.255.255.0. That's who can use it. The command to link them up. NAT from the inside network going towards the outside should be dynamically using a pool called pool 1. I need to put that in over here. I forgot to do that. NAT inside comma outside dynamic pool 1. So this is where I'm linking the pool. I'm basically saying this subnet, I'll just do it as a highlight. This subnet that has been defined over here on this interface, when it tries to go towards what? This interface should be using what pool? I'll put that in a different color. It should be using pool 1. So that basically means when 10.11.11.1 is trying to go anywhere on the outside, it will automatically be using, if the destination is on the outside network based on routing, it's going to use this pool to get translated. So this 10.1.1.1 will be translated to somebody on this range. The destination does not change. I'm not doing destination NAT. This is AutoNAT. This is the syntax for AutoNAT. Any questions, guys? Clear on this? Syntax okay? So let's try it. What I'm going to do over here is I'm going to go to router 2 and enable telnet over here. All right, Cisco login done. I'll go to router 1. We'll take a look at this first, understand each one by itself. We'll take a look at the preferences later on, because you haven't taken a look at the other ones yet. So understand each one first, and then we'll talk about that. So line VTY 0 space 4, password Cisco, login. I'll go to router 1 now, and I'll telnet to, let's say, 20.2. I'm in. Cisco is my password. If I do show users, it should tell me that I'm connected in using 20.108. Any address in that pool of addresses that I have from 101 through 200. You can also see that over here on the ASA in your xlate table. Xlate is the command for translate. That 10.11.11.1 on the inside is translated to what? The outside 20.108. This is known as dynamic NAT, also known as source NAT, because I'm translating an internal address. It is also referred to as object NAT or auto NAT because of the command syntax that I used. So in this example that I have, I've shown you how to do what? Translation from where? Of my internal users going to the internet using what? A address from a pool. Dynamic NAT. Generally used for what? In to out. Good so far. Now, inside to outside. So every time I go out, I might technically use a different available in the pool. I'll pick it and go out, get translated. Clear so far? Now, what if I'm going to hypothesize over here? Let's say I have 3 servers down here on my DMZ. I have a .11, .12, .13. .11 is, let's say, my web server. .12 is my, let's say, email server. And .13 is my DNS server. I want people on the internet to access them. Can people on the outside access this address? 192.168.1.11, 12, or 13. Can they access the 192.168.1 network? The answer is no. Why? These are all private addresses. So I need to translate them. Now over here, I cannot do a dynamic address change because if I want my users on the internet to access these servers, I cannot give them a moving target. I need to statically translate it and create an entry in my translation table. So when I create a one-on-one translation, it actually creates an entry in the translation table immediately. I don't need to wait. With the dynamic NAT that I showed you in the previous example, when my users try to go out, it did not have a translation entry in the translation table. So went to the pool, picked an address, created the translation entry. Here, the translation entry is created as soon as I put the command in. Good so far? I'll show you the command for it, but understand it first. So when generally do I do static NAT? Normally I do static NAT for my servers because people are accessing these servers from the internet. Generally, I would not do static NAT for my internal PCs going towards the outside. All right. So normally from in to out, I use dynamic NAT. From out to in, generally I would use static NAT. Clear so far? So how do I do it? How do I do the static NAT? What's the syntax for it? Let's write the syntax. So this was source dynamic NAT. Now I'm going to do source static NAT. Why do I use the word source over here? Source is my translation. My address is getting translated. Translates an internal address on the outside. This is done statically so that an entry is created in the translation table. All right. You still need to allow access from low to high. So just because you created a translation entry does not mean people will be able to access it. You still need to create an ACL entry. So how do I do that? So the first thing, I don't need to define a pool or anything like that. I just create the static entry. I'll create 4 entries for 11, 12, 13, and I'll also do something that I can test because 11, 12, 13 are all hypothetical. I want to do it for router 3 so I can actually test it. So I'm going to do it for my web server. I'll say object network, same command, but I'll call it www1, web server 1. I'll specify my IP address, my internal IP address. Let's say 11. Translate it. It's on the DMZ, so I'll say DMZ outside static. Let's translate it to 21. My email server, object network, let's say email 1, because you might have multiple email servers. In later on, let's say 12, NAT, DMZ, static, 20. Let's say 22. And the third one was my DNS server, object network, DNS1, host is 13, NAT, DMZ, comma, outside, static, 20.23. And the last one was router 3. Let's call it router 3. This is the one that I can test because it actually exists. 20 dot, let's say 24. Good. Now I need to allow access to it. Access dash list. Let's call this ACL outside because I'm going to apply it to the outside. Permit TCP. Anybody can come in to host 192.168.1.11 EQ 80. And let's say it's also supports 443. I also want to give access to my email server, which is at 12. I want to give access to 23 on 3. And I want to give access to 53 on 13, which is UDP based. And once this is done, I'll apply the ACL just like we did the last time around. Access dash group in interface outside. You guys understand this? Everybody okay with this? I'll just put a exclamation mark so it doesn't give me an error. Copy it. Now, the thing about static NAT is that as soon as I create it, it creates an entry in my translation table. You'll notice that it is creating an entry. It specifies that NAT is done from DMZ to the address of 192.168.1.3 to 20.24, 1.11 to 20.21, 12 to 22, 13 to 23. Now, coming back to your question, somebody asked the question, if I have a one-on-one NAT versus a dynamic NAT, it'll prefer the static NAT because the dynamic NAT will never be created. Because the static NAT takes precedence, it will be in the translation table. You don't need to create it. Good. Now, can people access R3 for Telnet now? Let's open it up. So R3 is ready for Telnet. I'll go to the outside. What do I Telnet into, guys? Can I Telnet into this guy? No. This is a private address. It will not be available on the outside. So I need to Telnet into what? The translated address, which is 20.24. If you guys remember, on ASA1, 192.168.1.3 is translated to 20.24. So on R4, they know R3 as 20.24. Again, this is still source NAT. Why is this still called source NAT? Because source meaning what? My internal address is getting translated. My 192.168.1.3 is seen on the outside as 20.24. So when I press enter, I'm in, I can check. R3 is accessible, and if I do show users, it'll tell me that 20.2 has telneted in. Everybody okay with this so far, guys? Static translations for your public-facing servers. So generally, your public-facing servers, you'll have static translations for. Your internal users going outside will have dynamic translations. Clear so far? Questions, guys? Syntax okay? Let me know if you have any questions regarding the syntax or how it works. One thing that I want you guys to notice as well over here is the order in which I put the name of the interfaces. I put DMZ first and outside second. No, dynamic and auto NAT is not necessarily the same. Object NAT and auto NAT is the same. I can do dynamic even with twice NAT or manual NAT. Object NAT and auto NAT are the same. All right. So I want you guys to pay attention over here to something. Notice in the NAT statement, when I put the NAT statement in, I put the name of the interface DMZ first and then outside. All right. In the dynamics statement, I put inside first and then outside. Either way, you need to remember one thing, that the address that it's going to try to match is this address on the first interface, this address on the second interface. Same thing over here, the pool, which is the public address, this guy over here, on the outside interface, and this address, this range of addresses, which is your subnet, on the inside. So it's always like this and that. So this way for the host and the inside network, and then this way for the public side. For right now. But this matching is always a case. So the host and the NAT, or the subnet and the inside, always go hand in hand. The first interface goes with this guy, and the second interface goes with the address available over here. Now the order which you generally do, again, I'm putting a general statement over here, 99% of the time, the first interface over here is the interface with the higher security level. This is 100, and this is what? 0. So 0 with this, 100 with this. How about over here? 50 with this, lower, which is 0 with this. So if I had to write a generic statement, I would say whatever address is over here, the first line address, I'll put it in blue. First line address is always going to be, not always, 99% of the time, is going to be a high address. High means what? Generally a internal address, high, okay, which maps over to the first interface. And the second interface is the low interface, which maps over to this external address. Which is going to be low. All right. High internal, low external. This is going to be the low address, low interface. This is going to be the high interface. So take a look. High meaning internal, internal interface, outside, outside. So always high, low. Not always, as I said, what? 99% of the time. Okay. Good. Now, this is a rich company. Why do I say it's a rich company? The reason I say it's a rich company, it got how many addresses? It's got a bunch of public addresses, 254, because these addresses cost money. That's why I said it's a rich company. Let's say I don't have that many addresses. I got 2 addresses or 3 addresses assigned or 4 addresses assigned to me. All right. And I want to play around with those 4 addresses. I have a whole bunch of what? Dynamic internal addresses that need to go out. Plus I have some public servers as well. So the addresses that I have on router 2, I've already used up .2. On the firewall, I've already used up .10. And let's say beyond these two, the ISP has given me .5 and .6. Those are the only addresses that have been assigned to me. So what I'm going to do over here is I'm going to use a single address to be used for all my internal users. How can I do that? How can I have a single address on the outside be used by everybody on the inside? By using that, or port address translation. It also changes the IP address, but in conjunction with port numbers, so that I have a unique entry. So for example, if I have a single address .5 on the outside, so I'll say 192.1.20.5 is my public address. Internally, I have the whole 10, 11, 11, 0 range trying to go out. How would I allow them to go out using a single address over here? What I would do is I will say, hey, listen, use port numbers to make that, what do you call it? Distinction. Or if you want, you can even use the outside interface. For example, I have the outside interface of my, what do you call it? My firewall, which is, let's say, .10. I can even use that IP address to be shared by everybody. So when anybody on the 10.11.11 network tries to go out to the outside, let's say 10.11.11, I'll put 2 or 3 addresses on the inside. Let's say 31.32.33. They try to go out. I want them all to be translated to 192.1.20.10. But how do I make a distinction if all of them are going out using the same public address? Because they all are going to use the same interface address to go out. This is 32. The way I'm going to make that distinction is by using the port number. So over here, whatever the random port he selected by default by the client, let's say the port number that he selected trying to go out as a source address, source port number was 2111. I'm going to use the same thing in my translation entry. If he used 29,900, I'm going to use the same thing in the port number. I'm going to keep the port number translation entry in my translation table. What if I have another client who randomly selected the same one as 31? Well, in that case, what I would do is I'll need to make a distinction. So I'll give a different port number, let's say 21115. So I also change the port number over here. Because I'm using a conjunction of IP addresses and port number to make the change, it's called PAT, or port address translation. So I no longer have a pool of addresses, I have a single address. And even that, I can use the outside address of the interface to do that. All right, I'll show you the different ways of doing that. This is called PAT. Everybody okay with the concept so far? So first things first, I'm going to get rid of what? My existing NATs and PATs. So over here, I'll go to ASA1, clear xlate, clear configure, object. We'll get rid of all my object commands. Show run object should be gone. So I don't have any of the translations that I did are all gone away. PAT, different ways of doing dynamic PAT. One way is a simple way of doing it. Object network inside INS net, which is my inside network. I got rid of it, so I'm creating it again. So I want this internal network, which is on the inside, going towards the outside, to be dynamically translated to the interface. Which interface? Remember what I told you. This address, the inside address, goes with this guy, right? And this address goes with this. When I say interface, it's pointed to the outside interface. What basically I'm saying is everybody on the inside from the 10.11.11.0 network, when they try to go out, use the outside address of the outside interface as the public address. Or I'll show you this and I'll show you the other way of doing it as well. This is the easy way of doing it because, and not only easy, it's also more efficient because I'm not wasting any addresses. I'm already short of addresses, so might as well save it. This was source NAT, so now I'm going to do dynamic path. How do I do it? One way of doing it is this, using the outside interface, object network, INSNet, subnet, NAT, inside, comma, outside, dynamic interface. That's one way of doing it. Or second way of doing it, using an IP address. So in this case, A, create an IP address for pool of IPs, because you're doing too many translations. There's a limit of 64,000, which is a lot to be done based on a single address. If you need more than that, create a pool of addresses. You can even create one. That's okay. You'd still need to create it. Object network, let's call it PAT, or pool A, whatever. Pool A, just a name. Host, I'm just going to give a single address, .5. B, create the inside network and specify to use the pool for PAT. Object network, INSNet, one or the other. I'm not going to do both. I'm just showing you that you have the ability to do both. NAT, inside, comma, outside, dynamic. The keyword is PAT, pool A. I'll just show you. We won't do it, but you guys can see it at least. Oops. Object network ABC, just to show you that you can do it, or the syntax for it. So if I had to do it like that with a pool, I would do inside, comma, outside. I would have created the pool, dynamic keyword PAT pool. That's the keyword over here. So you can either use the interface over there or the keyword PAT pool and then the name of the pool, whatever you created, pool A, for example. But that keyword PAT pool needs to be there so he knows that it's doing PAT. Everybody okay with that? So you guys understand how to do PAT? I've done that already, so let's test it if you see it. Let's see if it works. So now I'll go to router 1 and try to telnet to the outside. Say telnet 199.1.1.1. Show users 20.10. 20.10 is my outside address. So if I go over here and I do show xslate, now you'll see that the port number is also being used. Before it was not there. All good, guys? Everybody okay with this? And notice it's using the same port number. What was the initial one? It uses the same one. It doesn't need to change it. It will only change it if there's a conflict. Good? All right, so this is dynamic path. Now, for the same reason, same example that I gave you, I had multiple servers down over here. Remember that? The 3 servers, dot 11, dot 12, dot 13. 11 was web. This was, I think, email. and this was DNS. And I want to use .3 as my router so I can test it, because these are hypothetical servers, right? So how do I do it using path? I could use the interface if I want to, or let's just use a different address over here for path. Let's write that down in Notepad first, and then I'll paste it. This is static path. So for my public facing servers. So again, I have a shortage of IP addresses, so I can do a one-on-one type of thing. I'll do object network, let's say www1, my first web server. Internal IP address is 192.168.1.11, NAT DMZ comma outside, high to low, static, 20. Let's say 11. Now, any difference over here so far? It's exactly like your static NAT, isn't it? Right? Yes, everybody? Okay. Now, if I want to make it into PAT, the key thing over here is service, followed by the protocol. I'm doing it for a web server, which uses TCP as the protocol. The port numbers, again, in the order which you specified this. What port number do I want to use on the DMZ compared to the outside? DMZ, it's a web server, so port 80. And on the outside, I'm not doing a port translation. I'll keep it as 80. So what I'm basically saying is, if I receive a packet destination of 20.11 as the destination IP, but with a port number of what? Port 80, send it to whom? Change it to what? 192.168.1.11 for port number 80. Similarly, what I'm going to do over here is, I shouldn't have done that. That's okay. I'll just write it again. Object network. Let's say this was my email server. Host. Internal address is 12. NAT DMZ comma outside. Static 20.11, same IP. Oh, I didn't put the port 80. Same IP, but this time around, service TCP 2525. Object network DNS1 host NAT DMZ outside static 20.11, same IP, UDP 5353, and my fourth one, the actual device that I can test, R3 NAT DMZ comma outs. Oops. It's been there for too long, so I'll connect in again. Yep. Outside. Same IP, service TCP 2323. You guys understand what I'm doing over here? Basically specifying that if the port coming into the IP in all four cases is what? So when the packet hits your firewall on the outside, for all those four servers, whether it's 11, 12, 13, or 3, the destination IP will be the same. All right? How do I know whether I need to send it to .11, .12, .13, .3? By looking at the port number. Which port number over here? The first one or the second one do I check? Remember I said in this order. So if I want to check, I'm going to check the second address of the packet coming in, and that is going to be the second port. So it's in the order of this. So the second port is outside. So on the outside, I'm going to check 53 and send it to 53, 23 to 23, and so on and so forth. Now, if you want, Again, you don't need to change it. You can say 8080. If you want, you have the ability to even change this. So for example, I don't want people to know my telnet is 23. So what I can do is I can do what is known as port redirection. Port redirection basically says, I'm going to use a different port number on the outside. And I'll tell my person that is telnetting in, hey, listen, telnet into 23111. So when the packet comes into the outside interface for 20.11 for port number what? 23111, it's going to change the IP to what? 23111 on the outside. The IP should change to 1.3, and the port number should change to 23. This is called port redirection. Whereas this guy, what I'm not changing the port, I'm just using it as a mechanism of making the distinction. This is called port forwarding. Both fall under the category of static path. So the technical term is static path. 23 is internal, 23111 is what is seen on the outside. Can I use the same public IP for static path that we use for dynamic path? Yes, you can. So I could use the IP for that as well, because it's a dynamic, what do you call it? Port number that you're going to use. So you can technically use the same address for everything. All right. Let's do this. Let's do this part on my firewall. On the ASA, this was my dynamic and my translation was done. Now what I'm going to do is I'm going to do my static, including, that's okay, just ignore that message, show xlate, it should have created it. The port number translation is done. This is on the outside. Now, do I need to change my ACL? Remember, although I blew up my objects, my ACL I didn't touch. So my ACL is still in place. Is this ACL, does this ACL need to change? Oops. Or is this ACL okay? The ACL is okay because the ACL, in the ACL, I put the real address. I did not put the public address. So my real address, my actual internal address didn't change. My public address changed. Before I had a different translation, now I have a different translation, but my ACL is still pointing to my private address. So it's still allowing access to 1.3 for telnet. The only thing that you need to now remember is, as I showed you over here, I need to tell my users that they need to telnet into what? 20.11 for port 23111. So if I go over here on router 2 now, and I telnet in like this, should it work? Will this work? Why not, Rinchen? The translation is not going to work because it's not going to work, Raza, because the translation is for what? 2311. And this is going to send the packet to 23. And it's not going to translate. It's not going to translate that 20.11 to 192.168.1.3 because the address doesn't match. So if I try to do it, it's not going to work. You would need to specify the port number. Absolutely. I just want you guys to see it's not working. It's eventually going to time out. So now what I'm going to do is 2311. Boom. You understand that? So that's static path. Good, everybody. Did I put the notes already? Yep. So if you take a look at what we have to do in terms of this, we have done these 4 NATs. You guys agree? Dynamic NAT, static NAT, dynamic path, static path. We've also done the access policies. Access policies in the sense of the ACLs. Now the XLate won't change because XLate was already done up front. Since it's static, yeah. Everybody okay with this? You guys understand? Sure, 1 second. All right. So now the fun part. You guys remember we talked about that mainframe without the default gateway part? First ACL check, then NAT? No, the other way around. The first thing that happens is NAT, then the ACL is checked. Because if the ACL is checked first, that is old. What you're talking about is old, like 8.2 and before, Abid. Over here, if you look at your ACL, ACL is pointing to what? Let's say 192.168, the private address. When the packet comes from the outside, it's pointing towards 20.11. If it checked the ACL, it would not match, right? So the first thing that happens over here is this gets translated to a destination of whatever, and then it gets checked against the ACL. So in this case, in anything above 8.2 or 8.3 above or above, the order of operation is always NAT first and then the ACL. Good, everybody? You guys understand this? The issue with that, Zahir, is this. The Cisco used to have that. The difference is, let's say I have an ISP today. And my ISP is 192 given me this address. They own this address. So all my translations are done to the 20 address, right? So based on ACL check first, I would need to put what address in my ACL? The public address, right, Zahir? So I would put the addresses as 192.20.x, 20.x, 20.x. Let's say I have 100 entries like that because I have a bunch of different servers. Tomorrow, I change the ISP. From ISP1, I change it to ISP2. ISP2 has a different range of addresses. They don't have this. They have, let's say, 195.110. So now I need to change my static translation. That's okay. But I also need to change these 100 entries over here in my ACL. Correct? Because all the entries are pointed to the public address. With this way we're doing it, my ACL is always pointed to my private addresses. Even if I change my ISP, I would not need to change my ACL entries because my ACL entries are pointed to my private address. So just in case you move from one to the other ISP, I would not need to do any change. What do you mean by how NAT check is done? It hits the outside interface, it checks the routing, it says the packet is destined from the outside interface to the DMZ interface. Let's do the NAT first, and then if it's after the translation, let's see if it's matching an ACL to see if it's allowed or not. It's not actually going there, but the routing tells it the destination is the outside interface. Okie doke, let's do the destination NAT now. Let's assume that this guy is that mainframe computer. So I'm going to get rid of all my entries, my NATing and all that. So we can do this from scratch. Clear configure. Object gets rid of all my object NAT. Show run object gone. Show xlate. If there's anything, should take care of it. There's nothing there. I'll just do it anyways. Clear xlate. Everything is gone, right? Now, what I want to do is I want R3 to be accessible from the outside, but this is the issue over here. No router RIP. Check my routing table. What do I have in my routing table right now? What do you guys see in my routing table? Just my directly connected networks, which is 10.3, which is the loopback, and 192.168.1.0. Everybody following along. Guys, pay attention to this because this is not normally done. But on the exam, you can easily get asked this. Good so far? All right, so with this in mind, this is done. What I want to do is I want R2 199.111, this guy over here. Let's say, assuming that 199.111 is the other, what do you call it? Mainframe on the internet. I want 199.111 to be able to access R3 from the outside. Okay, but I cannot put a default gateway in R3 because it does not have routing capabilities, hypothetically. First things first, I want to do my normal source NAT so that R3 is available on the outside. So I'll say object, network, whatever you want to call it, R3, 192.168.1.3, translate that to DMZ comma outside, static, and I'll say 20 dot, let's say 20, doesn't matter, just an address. My ACLs are still in place, so 192.168.1.3 is still available. All right, I'll do a debug IP packet over here. I'll go to R2. I'll telnet to 192.1.20.20. Source interface loopback 199. Let's see if the packet comes in over here. Notice the packet from source 199 is coming into 192.168.1.3 because of the translation over here. The translation is over there. So the translation is there. Because the translation is there, the packet is going to come in. You guys understand that? But because I don't have a default gateway, the packet is not going to go back. That's why you see this unroutable over here. You understand that? Good so far? Now, the trick over here. Do you guys remember I showed you that object network command? Not R3. Object network command XX. I put the host address over here, and then I put NAT, and I put the high interface over here, and low interface over here, the keyword static, and the low IP over here. This was the high IP. High IP meaning IP address that's related to that. This is related to that. Everybody understand that? You guys remember I spent some time on showing you that? I told you that 99% of the time, this is what you do. Yeah? Everybody follow along? Now, the real truth. The purpose of this, although it's easy to remember high, high, low, low, the actual thing is this interface. The one in the first slot over here checks the source address. This interface over here checks the destination address. So what do I mean by that? Let's change these IPs over here. Normally, when I do the normal translation, let's say I did it for R3. Help me out with the R3 translation. What did I put over here on the host? Here, I'll put it in different colors. What did I put over here? No, not low. I put high over here, right? High meaning high security level interface, right? Local IP, right? And then I put DMZ over here because this address is on the DMZ, correct? And then over here, I put the keyword outside, not keyword, sorry, the interface outside, which I map the low, which is the low interface, and map it to the low IP, the public IP, right? Agreed? How does the firewall know to change this address to this address or change this address to that address? The way it does that is the significance is over here. It tells it what to do. What did I tell you about the first slot? It only checks the source address. The second checks the destination address. So when the packet comes from the outside, what does the packet look like? If somebody's trying to access my R3, what does the packet look like? Help me out with the packet. Some source, destination what? Sorry. Yeah, I don't care what the source is because I'm not even doing the destination part. Just want you guys to see the normal one. Let's say 199.111. This is what? $20, let's say 5. right? Let's say this is 5 over here. Agreed? Which interface did the packet come in? Did it come in on the DMZ or the outside interface? Outside. Outside is in what place? The first slot, the second slot? Second slot. What did I tell you about the second slot? What does it check? That's the actual thing that that is never going to change. So the second slot always checks the destination. Against what? The corresponding address. Remember, I had already linked this up. I told you this is linked to link. This is linked to this. So on the outside, I received the packet on the outside. Hear me out, guys. Pay attention. Because the packet was received on the second slot interface, on the second slot interface, it only checks the destination against the corresponding address. Is it 20.5? Yes, it is. Because it's 20.5, it's going to change it to the corresponding address. So it's going to change it to what? But the reason it did it, because the packet was received on what interface? Outside interface. Now this packet gets sent to whom? To R3. R3 gets it. R3 responds. Right? Let's say I'm not doing that mainframe example, non-routed example, normal example. R3 responds back. It hits the firewall. Which interface on the firewall does it hit? The DMZ interface. Now, DMZ is in the first slot or the second slot? First slot. What did I tell you checks in the first slot? The source. Does the source match? Again, remember I told you it matches this. Does it match 192.168.1.3? Yes, the source is 192.168.1.3. So change the source back to what? Its public address. You understand how it performs that? By looking at the flow of the interfaces. So you can read 100 books. You will not see the source and destination in there. You wouldn't even know why you would put the high here and a low here. It's because of this. Because the interface that the packet is received on, if it's in the first slot, it will always check the source. If it's received on the second slot, it will only check the destination. Now, why did I go through so much detail to explain this to you guys? Now what I'm doing over here is I want this guy that's coming in from the outside, which has an address of 199.111, coming into your firewall, going towards R3. R3 is 192.168.1.3. I want 199 to be translated as if it's somebody local because he does not have a default gateway. Remember, destination NAT. I want this guy, the remote address, to be seen as if it's what? Local over here. What does a packet come out of R2 as? Help me out with the packet. .199.111, 192.1.20.20. I think that's what I translated R3 as, right? Hits this interface, the outside interface. I already have that normal one, which is going to change this to what? What statement does that? That statement that says host NAT DMZ comma out static 20.20. So the packet is received on the outside interface, second slot, check the destination. Destination matches 20.20, change it to this. Done? Now what do I need to do? I need to change this 199 on the local. How would I write this statement? Object, network, whatever you want to call it, XXX, Host, what address do I want to change? Source or destination? Do I want to change the source or destination? No, I mean, in terms of the packet coming in. Where's the packet coming in from? 199, right? I want to change him, right? Which interface does it come on? Outside, right? So I want to change 199 on the outside interface. So I'll say NAT outside, comma DMZ. What that means, if, remember, source and destination, if this 199 comes in the outside interface, check the source. The first slot is always a source. If 199 is in the source, change it to what? Static, and give it any unused address where? On the inside, let's say 79. So what it's going to do over here is this packet came in into what interface? Outside interface. Outside is in the first slot. Check the source. Is the source 199? Yes, it is. Change it to what? So this statement, the way I'm going to write it, if I want to do destination NAT, is like this. This is just a name, H99, 199, host, 199.111 when it comes in. Which interface? Outside, comma, DMZ, static, means if 199.111 comes on the outside interface, change it to whatever address, any unused address on the DMZ interface. Understood? So I'm going to flip it because I'm receiving what? This on the outside as a source, and I want to change the source. Up to this point, I was doing it the other way around because this was coming in on the DMZ and this was coming in on the outside. But now I want to use the public address on the source side, change it to inside. This is called destination NAT. Why is it called destination NAT? I'm actually changing the source. The word destination does not refer to the destination IP. The word destination refers to what? Foreign address, remote address, whatever you want to call it. Good. Let's do it. Yeah, you can do dynamic for this as well because you can say anybody coming from the outside and you can put a subnet over there and then specify everybody on the inside uses this single address, like the address of your inside interface. So now if I do it over here on ASA, I've done my first translation, I believe. I can say show NAT details. Yeah, 20.20 from DMZ to outside. Source, it'll translate it to 190 to 168.1.3. Now I'm going to do what? Object network, host 1999. I have too many nines, it doesn't matter. Just a name. NAT outside, comma, DMZ. So in this case, it's a low high, not high low. Static, any unused address on this interface. Now on R3, service is only if I'm doing PAT. I'm not doing PAT, I'm just doing normal destination NAT. So if you take a look at this now, show IP route. no default gateway, no route towards the 199 network. If I go over here, telnet to 192.1.20.20, but use a source interface of what? Loopback 199, because that's the only translation I've done. That it should go over there, translated as 192.168.1.79. It's coming in, it should work. Sometimes it times out, so you might need to do it twice. Let's try it one more time. There you go. I'm in. Take a look. Show users who's connected in. I'm not connecting as 199.111. I'm connecting in as 192.168.1.79. So 199 was translated on the inside. This is destination now. Again, as I said, not normally done. Very rare to do this. But I want you guys to be able to do that on the exam if they ask you. Good stuff. Is it in your thing? Yeah, I put it in there. And believe me, if you read this, it's not there. The examples, why do you flip it? It's not there. Thank you, thank you. Now, all I've done is what is known as AutoNAT. What is TwiceNAT? Or also known as ObjectNAT. What I'm going to show you now is another type of NAT, which is known as manual NAT or TwiceNAT. What is that? Exactly what I did over here. What did I do over here? Actually changing the source and changing the destination, didn't I? I changed the source from what? 199, it was coming into 20.20. Once the translation was done, it was changed to what? And this was, you guys agree? Didn't I do that? So I did a source NAT and a destination NAT in two statements. One for what? Source NAT and one for destination. Agreed? Normally speaking, normal NAT that I do, I don't do twice NAT. Remember, if I normally go out, I'm either changing it's always generally, as I said, normally you're just changing your address. So from in to out, you're changing your source address, destination remains the same. Out to in, you change the destination address, source remains the same. So normally speaking, this is not required. Normally speaking, one second, guys, one second. Sorry about that. So generally speaking, you either change the source or you change the destination. You guys understand that? You don't change both the source and destination. But if I'm doing something like that, rather than writing two statements to do it, if you really look at it, how many statements did I write right now? I'll just do it in my Scratch file. I wrote two statements over here. One, I wrote like this. High, low, in which I translated myself on the outside as this guy. And then I wrote another statement, which was this one, the destination at statement. Sorry. Didn't I? Which actually changed two things for me, changed the source as well as the destination. Agreed? Now, the same thing could be accomplished in a single line using a different statement. Both, this is still called what? Object nav, or also, as I said, called auto nav. This is one way of doing, but I need to write two statements over here. The same thing can be accomplished in a single statement. And when I do a single statement that changes what? The source and destination, checks the source as well as the destination, it's called twice nav. So I'll write that down for you guys over here. It allows you to change the source as well as the destination in a single NAT statement. This is also known as manual NAT. You guys understand that? So earlier on, somebody was asking me when I did the destination NAT, is that twice NAT? Remember that? Somebody was asking me that. What I did, this is not twice NAT. Although you might think it's twice NAT because it's changing the source and destination as well, but it's not considered twice NAT. Why? It's two separate NAT statements. Here, with twice NAT, I can do the same thing. I can translate the source as well as the destination, but in a single statement. That's twice NAT. And in terms of preference, if you have a twice NAT statement, it takes precedence over all the other type NATs. In terms of the priority, it works like this. It checks for twice NAT statements first. All right. If there are no twice NAT statements that match, then it goes into auto NAT. Inside auto NAT, it checks for what? Static and then dynamic. Somebody was asking me for the preferences. So the first preference is not based on auto, static, or dynamic. It's based on what? Twice NAT, which is also known as what? Manual NAT. I'll show you how to do it. Don't worry about the command syntax, but understand the philosophy behind it. So when would you want to use twice NAT? As the name suggests, if you're changing the source and the destination. How often do you change the source as well as the destination? Do you do that often? Think about it. Yes, no? Do you change both? Very rare. Because you're not changing the remote address at all. You're changing your address, internal address. Remember what we call source NAT. So how do I do it? How do I do twice NAT? First thing, get the 4 addresses involved, put them as objects. Let me do that over here. Again, I'm going to get rid of all my translations. Clear configure object, clear xclear. So everything is gone. So to do twice snap, the first thing I need to get is all the addresses. So we'll do the same destination NAT example that we did, but this time around, I'm going to do it based on what? Twice snap. As I said, Fahad, very rare, because what did I tell you about twice snap? It's only when you change both the source and the destination. How often are you going to change the destination? Not very often. So again, it's rare. So just the same way that you did destination NAT over here, I just showed you for the mainframe. We'll do the mainframe example right now based on twice NAT. I'll give you another example for that. That's when you have overlapping subnets. When you merge companies, you might have two private addresses that are the same. So if you're doing a VPN between the two, you might want to change the address of the other side. So that's where you would say, oh, if the address is coming from the other side, translate it to an internal address. Generally with VPNs between two merging companies. So when you have an overlap of IPs, but normally very rare. And it's not a long-term solution, even at that point. It's just until you complete the merge and change the IP addressing scheme, and eventually you take it out. So how do I do it? First thing, if I wanted to do this example that I had, that I want my address to be changed on the outside and 199 to be changed on the inside. How many addresses are involved over here? Help me out. Write those statements, write the 4 addresses involved in this translation on your tab so I can see it. What are the 4 addresses that are involved in this particular example that we just did? R3, the inside address, and the outside address. What are the 2 addresses? Come on, I'm waiting. What are the addresses, the IP addresses, whether private or public? What are the addresses involved in this translation? I want the 199 to access my R3, with R3 not having a default gateway. So host, I'll just create an object entry for that. Let's call it R3 original, or R3 on the inside, what I need to call it on the inside network, or DMZ, whatever you want to call it. What is the address on the inside? 192.168.1.3. Isn't that true? And what is the address of R3 on the outside? O for outside. Correct? And then similarly, I'll just say host 199 on the outside. What is the outside address of 199? And what is the address of 199 on the inside? We'll call it 199D for DMZ. Remember, we had that address that I picked. You guys understand the 4 objects that I created? These are the 4 addresses that I need to use, right? So first thing that I need to do is I need to create the objects for each IP address that I'm going to use in TwiceNAT. Good. Number 2, create the TwiceNAT statement. What is TwiceNAT also called? Let me explain how. NAT source static. All right, static. Now, if start the flow from in to out. If I started the flow from inside to outside, how would it look? What would the source be? What would the packet look like from in to out? From DMZ actually. Just focus on that flow. It would start from what? 192.168.1.3. Destination will be what? Nope. Destination will not be 199, it'll be 79. Right? On the DMZ network, router 3 does not know 199. He only sees 79. Correct? And I want to change this 192.168.1.3 to whom? And I want to change this to what? So on the DMZ network, when the packet leaves, it leaves from what? 192.168.1.3 towards 79 on the DMZ. And that would change on the outside 20.20 going to 199. You guys agree? Isn't that the packet format? This is the firewall in the middle. This is the DMZ network. This is the outside network. Agreed? So now source, I want to change it. I want the source. What would the source be? Source would be 192.168.1.3. What is the name of that object? Change R3D to R3O when the destination is when R3 is going towards what? This guy is going towards 192.168.1.79 H199-D. Change that to O. So basically what I'm saying is if the packet is going from R3D towards 199D, change R3D to R3O, change 199D to H199O. You get my point? That's what your twice NAT is. So change the source to this and destination to that. So let's take a look at doing it. Let's do it over here. Create the objects, object network, R3D, host 192.168.1.3, object network, R3O on the outside, host 192.1.20.20, R3 on the outside is seen as that, object network, host 199 on the D, DMZ is seen as 79, and H199 on the outside is seen as, once my 4 objects are created, now I can write the NAT source static. R3D should be changed to R3O when the destination is H199D. Change H199D to H199 outside. So one statement that does both. Good. Now, if you want, you can also specify the interfaces. So if you want, you don't want to leave it open, you can also do this. NAT, DMZ, comma, outside, source, and then you can specify the same thing. So you're locking it down to a specific flow from one interface to a specific interface rather than open-ended. Show run NAT, and there you go, from DMZ to outside. So now, and it automatically, once you flow with one direction, the reverse direction is automatically done. So now if I go to router 2, telnet to 20.20, source interface, loopback 1999, I'm in, who's my NS. So same thing that I did, but in a single statement. And if you want to check something else over here, you can do show NAT details. Notice what it's calling it? Manual NAT. What is this, section 1? Section 1 is your manual NAT. Auto NAT is your second section. So if I want to do my normal NAT now, let's say in to out, for example, I can say object network pool 1, range 192.168.20.51 through 20.100. That's my pool. Object network inside net, subnet. And then I can specify my NAT inside, comma, outside, dynamic, and what did I call it? Pool 1. Show run NAT. No, sorry, show NAT detail. Manual NAT, section 1, auto NAT, section 2. So the preference is on this guy first. Everybody okay with this? So that's your manual NAT and auto NAT. This is also known as twice NAT. So don't get too caught up with the technology terminologies. This is your twice NAT. This is your normal NAT, also known as object NAT. Good with this? I went a little detailed slower than normal, but I want you guys to understand this, so that's why I did that. Hopefully it helped. So you can also, I'll also put this over here. Put the interfaces. I think this is good enough for today. I don't want to push it. There's only 20 minutes left. I won't be able to do too much with this. So this is what we'll stop at today. Tomorrow we'll start with transparent firewall and move forward. So we'll do transparent firewall tomorrow. We'll do redundant interfaces. We'll also get into the other redundancy part, like security context, maybe failover. Probably be somewhere around over here tomorrow. Transparent firewall, redundant interfaces, port counts, security context, failover. Probably do that tomorrow. Yeah. Good, I'm glad you guys liked it. All right, please check your emails, because otherwise what happens is once a return, anything that gets translated one way, it's in the translation table. The return traffic automatically picks it based on that. So check the port number based on that. Check your email addresses. Anybody missing over here? Because I'm going to send the documents right now. Let me save this. Mustafa, you're not there? You sure? You're there. Anybody missing? I'll include the physical topology, Oscar, but that would be for my rack. So it might be different for yours. All right, so looks like everybody's here. Copy. Close this for right now. So September 9th, security. Okay, first things first, let me get the files. Day 6, and I need the ASA. And then I need to add the physical topology, which is over here. Done. Check, you guys, see if you got it. Tomorrow, same time. Send me an email, Mustafa, which ones you need, I'll send it to you. Probably tomorrow, because I'm starting another class right now, right after this, so probably tomorrow. Zahir, tomorrow though, because I'm going to start another class, so it will create a lag otherwise. Just send me an email though, please. Whoever needs a recording, please send me an email. Send me an email, Manik. All right, see you guys tomorrow, same time. Take care. Thank you, bye now.